Yes, yeah. Welcome to the another session of the probability and statistics. So, in this session, I will start with the concept of your what I can say that the Bayes theorem and total probability. Bayes theorem and total probability. So, let me take that. Bayes theorem and total probability. So, let me take the statement for this. Yeah. If a capital E1, E2, E3 and so on En and so on En are mutually exclusive events, that you know that mutual exclusive events means what ma? One event is one event does not depends upon the another event in the same sample space. So E1, E2, E3 and so on En are mutually exclusive events such that capital A is arbitrary event which is a subset of union I is equal to 1 to n ei, which is a subset of all the E1, E2, E3 and so on En. Then actually the Bayes theorem probability they had given it as actually the thing that I will go with the proof. Let me take that condition. So then they had given the probability of the probability of Ei given A, which is equivalent to probability of Ei into the conditional probability of A given Ei divided by summation I is equivalent to 1 to n probability of Ei into probability of A given Ei. So this is actually the Bayes theorem statement. So let me go with the ideology how I have to solve this one. So let me take the proof of this one. Let me consider the proof. That is a statement actually. Yeah. So what they had given is they considered a sample space. So they had taken one sample space. Yeah. This is a sample space they had considered there. In the sample space, they taken E1 is a event, E2, E3, En minus 1 and En. These are the different types of events. So let me take this is an event, this is one event and this is also event and so on. You will have here what this is the another event and this is also the another event. Am I right or not? So likewise they have different events. So which are what ma? Mutually exclusive events. So out of which they taken A is any arbitrary event, and that arbitrary event is nothing but what ma? It is a subset of all the events. That means it is a subset of all the events, means it is a meaning of the subset. So which is A is any arbitrary event which is a subset of that event. Suppose if I want to take so where A is unknown event ma. So here actually the Bayes theorem which is used for the concept of your what ma. So here we are calculating the reverse probability that we will come to understand in the end of the thing. Am I right or not? So check it out here. A is my unknown event. So A is my unknown event. Actually the conditional probabilities happens with respect to what unknown events. In terms of known events I used to write it as, but here EI I know that, but A I don't know that. So that is A is unknown event, EI is what ma? Known event. So that means that it is a reverse probability. So in the conditional probability, generally conditional probability is used for what? Writing unknown events in terms of the known events. But here I am representing in the concept of your Bayes theorem the reverse probability. Am I right or not? So that is I am representing the unknown event in terms of the unknown event. So let me consider that. So here I want to calculate, this is actually the sample space, right? So here I want to take the values of, that is I want to calculate the values of your probability of A. Am I right or not? So this probability of A, I need to calculate it. So how I will calculate this probability of A? If you observe here, so A is an event which is a subset of all the events, E1, E2, E3, En minus 1, En and so on. Am I right or not? So which is a part of your what ma? The events. So hence I can take it as the probability of A unknown event. I can write it as what ma? Probability of A intersection E1 plus probability of A intersection E2. Am I right or not? Yeah. So the probability of A I can represent as what might is A. It is nothing but what the mutual exclusive events of this one. So hence I can represent as what this is a probability of A intersection E3 and so on. So finally I'll have it as what a probability of A intersection En will be there. Am I correct or not? So again this so conditional probability that you know that. Am I right or not? So usually conditional probability how I will represent it as conditional probability how I can represent as what ma? So I need to write it as what the unknown events in terms of the known events. So let me take that. So here I can represent it as probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So similarly plus and so on I can represent as what probability of En given En into probability of A given En I can able to represent it as. Am I correct or not? Am I correct or not? So this is the probability of the particular event. So let me take the generalization of this one. So let me take this as a generalization. Probability of A I can represent as what if I go with the generalization. So that is a probability of A is equivalent to if I take a summation I is equivalent to 1 to n probability of EI into probability of A given EI. I can mention it as. So this is what this I can call it as what ma? You can call it as what the total probability because A is with respect to an arbitrary event. So with respect to E1, E2, E3 and so on this one. So this I can call it as the total probability. This I used to call it as the total probability of unknown event because A is what ma? The unknown event. So which I used to call it as this is the total probability of an unknown event. Am I right or not? So probability of A which is equivalent to summation I is equal to 1 to n this one. So here if I go with my reverse probability here I need to represent it as the reverse probability. So let me take this as a probability of EI given A. Probability of EI given A means you have to represent as this, you know that probability of EI intersection A divided by what ma? Probability of A. So this I have to do it as again probability of A intersection A means I have to represent as what? I need to represent this as what ma? Similarly probability of EI into probability of A given EI divided by that probability of A is what just now you had done in the total probability. So which is summation I is equal to 1 to n probability of EI into probability of A given EI will be there. So this is the Bayes theorem EI given A which I can represent as what ma? That is a total based upon the total probability I am representing this one. So this is nothing but what ma? This I used to call it as what? This is nothing but the reverse probability. So reverse probability. So then you people will have a doubt that sir how I have to identify the given problem is belongs to Bayes theorem. So just they will give you the known events and unknown events and that too they won't mention this is known event, this is unknown event. By people have to observe the problem whether this problem is belongs to your Bayes theorem or not. You need to check it out. So for that what I will do is if you observe here what are the different steps I need to follow to solve a problem on the Bayes theorem? First, what I was done, E1, E2, E3 and En, which is nothing but what known events. So that means that the first most step what you people have to do is you need to identify the known events in the given data, and that too that known events must be what mutually exclusive events. That means that what if it is a mutually exclusive events means what occurrence of one event does not depend upon the occurrence of the other event in the same sample space in such a way that you have to select or you have to identify the known events in the given data. Then next one, what you have to do it as, you should take it as what you need to select the unknown events. So that means an arbitrary event, what I assumed in the statement. So which is A, that is an arbitrary event. Am I right or not? So that you have to select the unknown events, and that too, while selecting that unknown events, you have to keep in your mind that unknown event, it should be a part of what ma? It should be a part of what? Known events, because A is an arbitrary event, it should be a part of your E1, E2, E3 and so on En. So that is how you have to take it as. So first you have to identify the known events in the given data, then you need to select the unknown events. That unknown events also, it should be a part of what? It should be a part of the known events. So that is the second step. Then third step, you have to do it as what? You have to write the probability of unknown events in terms of the known events. So this only you have written now, that is a probability of A, which is nothing but what ma? A intersection E1, A intersection E2 and so on, like that. So that is unknown events in terms of the known events. Then after that, you go on with respect to what? The total probability you calculated. So total probability for what? Unknown events. Am I right or not? So that is the fourth step you have to follow it. So please kindly consider the steps involved in the Bayes theorem, so that that problem, while solving the problem, it may be a easiest thing. So that is the fourth step. Then finally you have to go with what ma? You need to determine the reverse probability, total probability of unknown events and reverse probability for the known events. So that is only the thing which you have to keep in your mind to solve a problem on your what? The Bayes theorem. So let me take the steps involved, the steps in the Bayes theorem. Steps in the Bayes theorem, you do it as. So let me take steps in the Bayes theorem. Steps in the Bayes theorem. So let me take the steps. What are the steps which is involved in the Bayes theorem? So let me take the first step. What I told you ma? Identify the known events. First we have to take it as what? Identify the known events in the given data. In the given data. So that must be what ma? Which is in the form of your what? Mutually exclusive events. Mutually exclusive events. So what are the known events you are identifying? That events must be what ma? The mutually exclusive events. Then what you have to do it as again? Next one, what you have to do it as? Select the unknown events. Select the unknown events. That unknown events also what ma? It should be a part of what? It should be a part of known events. It should be a part of known events. Am I correct or not? So this is the second step. Then third step, what you have to do it as? Third one will be what ma? Write the probability of unknown events. Write the probability of unknown events in terms of known events. Write the probability of unknown events in terms of the known events. Next what people have to do it as? Find the total probability. Find the total probability for the unknown event. Find the total probability for the unknown event. Then finally you have to do it as what ma? Reverse probability. So determine reverse probability for known event. Reverse probability for known events. So this is the steps which you have to keep in your mind to solve a problem on your what ma? The Bayes theorem. So let me take an example so that you people will have an idea. So let me take that example ma. So Bayes theorem problems. So recently this 2020 also one question they asked you. I'll give you that question also. Don't get bothered. So let me take this question ma first. Let me take the question. Based upon that you people will have an idea. This is an example. Yeah, let me take that problem. There are 3 coins. There are 3 coins of this. There are 3 coins of this. 2 are of these two are unbiased. Of these two are unbiased, and one is biased. And one is biased coin with two heads. With the two heads. I told you that unbiased means two faces are different, and biased means what? Both the faces are different. Both the faces are same. So here they given you what? One is biased coin with the two heads they had given. With the heads they had given. Yeah, a coin is drawn at random. A coin is drawn at random and tossed. A coin is drawn at random and tossed two times. It appears head on both the times. It appears head on both the times. Find the probability that the selected coin is a biased coin. The selected coin is a what? Biased coin. So read the question properly. There are three coins. Of these two are what? Unbiased, and one is biased coin with the heads. A coin is drawn at random and tossed two times. It appears a head on both the times. Then find the probability that the selected coin is a biased coin. So see here, it is an application of your Bayes theorem. Am I right or not? So they selected a one coin, but that coin they did not know that whether it's a biased or unbiased. That coin you have to select it as. While you selected that coin, it appears what? Might shown it was two times they tossed that coin. So whatever the thing, one coin is drawn at random. That is, one coin is selected and two times they tossed it as. After tossing the two coins, both the times it is shows what? Head. Am I right or not? So you don't know whether what I can say that whether they taken biased coin or unbiased coin, but they are asking what? The probability that the biased coin it is. So first you have to take it as what? The known event as well as your unknown event. So stepwise you follow it as, so that you can have an idea to solve this problem. So what is the first step here? What is the first step you people have to follow here? See, while solving this problem, you need to concentrate the different steps here. So let me take this one. There are three coins are there, out of which two are unbiased and one is what? Biased. Two are unbiased and one is biased. So first let me take what? So that means there are three coins are there, right? In this, two are unbiased and one is biased. Am I right or not? Yeah, this is what the thing. So total you'll have three coins. So what's the first step here? What's the first step here? Yeah, first step if I'm taking here, what I'll get it as, what is the probability of unbiased? That is unknown. First you have to take it as what? The known probabilities. Then you have to go with the unknown events. So what is the probability of getting unbiased out of 3? So you'll have it as what? 2 divided by 3. Then similarly, probability of biased, which is nothing but what? 1 divided by 3. So this is the first step. So which is nothing but what? The known events. So which is a mutually exclusive events. Occurrence of biased and occurrence of unbiased does not depends upon in the same sample space. So hence it is the mutual exclusive events. Then second one is what? Second one is what? You need to show it as what? The unknown event. So what is that unknown event? Let me take that unknown event E. I am taking it as. So what is that unknown event here? What is the unknown event here? Getting see, for biased or unbiased, you don't know that. So that is getting a head in 2 times. Getting a head in 2 times. For biased or unbiased, you don't know that. So that is my unknown event. Am I right or not? Then third step, what you people have to do it as? So this is the second step. So third step, you have to write it as what? Probability of what? Unknown event in terms of the known events. So that is, you have to take it as what? Probability of unknown. That is E given you unbiased as well as your what? E given biased. I have to do it as. Then what is this one? How I will do it as what? So E given event, that is unknown event, given what? Unbiased and biased. Am I right or not? So what is that event? They selected one coin and they tossed it 2 times. So at the 2 times it is appearing here what? Head. Suppose if it is a unbiased coin, unbiased coin means what? This is first time tossing, and similarly second time I need to toss it as. So these are the two things. If it's unbiased means what? What's the probability of getting a head? 1/2. Here also 1/2. The total probability will be what? 1/4. Similarly, biased means what? Head. So both the things head will be means what, ma? So here there is no two different faces, only one face with two heads. So hence it is biased means only head of base means 1. Again it is nothing but what? 1 only. So hence I'll have here what? 1. So kindly concentrate on this mark. See, for unbiased means getting head probability is 1/2, and for biased means getting head or tail, whatever it may be the thing, 1 will be the probability, because two faces are what? Same you are getting there. Am I correct or not? So this is the third step. I just written it as what, ma? Probability of unknown in terms of the known events. Then what is the next step? What's the fourth step? What I have to do it as? What's the fourth step I have to follow here? What I need to do is you need to calculate the total probability for the unknown events. So that is the total probability for the unknown events. So what is the total probability for unknown events? Which is the probability of E. Yeah, with respect to unbiased, with respect to biased. So that means probability of unbiased intersection that particular unknown event. Similarly, probability of biased particular unknown event. Am I correct or not? So this how I have to simplify it as what I'll get as here, ma? This is a probability of E, which is equivalent to what? Unbiased given. So here I have to apply the conditional probability. So that is the probability of unbiased into probability of what, ma? E given unbiased. Similarly, probability of biased into probability of E given biased. So I hope you know these values. What's the probability of unbiased? 2/3 will be there. Then similarly, E given unbiased means what, ma? 1/4. And probability of B will be what? 1/3 will be there. Then E given biased means 1. So if you simplify it as, you will have it as what, ma? If you simplify, you will get it as what? 1/2 value. So try to check it out. If you simplify this, you will have the answer as what, ma? 1 divided by 2. This is the probability of E. So that is the fourth step. Then finally, fifth step. What I have to do it as? What's the last step, ma? Here I have to go with the reverse probability. So reverse probability means what? What they had asked? The selected coin will be what? What's the probability of that selected coin as a biased coin with the unknown event? So that means you have to calculate what? Reverse probability. So here you can represent this, you can call it as the reverse probability. So that is probability of B given biased coin, the selected event will be biased. So that you have to do it as. So what is this value? You will have it as again conditional probability. Probability of B intersection E divided by what, ma? Probability of the particular event. Am I right or not? Then again that probability of B given E, I can mention it as what? Probability of what, ma? What I can mention it as? Come on, tell me here. What do people have to do it as? Yes, how I can able to mention there? Probability of B into probability of what? E given B divided by this probability of E you already calculated. So that is probability of E value directly you will substitute as. So probability of B is what, ma? What's the probability of B? 1/3. Probability of E given B 1 divided by that probability of E will be what? 1/2. So what is the answer for this? What's the answer for this? Which is 2/3. So that is probability of the selected coin is a biased coin will be the value of your what, ma? 2/3. This is how I have to do the problem based upon my Bayes theorem. So this is the part which you have to keep in your mind to solve a concept of that is a Bayes theorem. Getting what I'm saying there? Are you getting what I'm saying there? Yeah. So can you try one more example? Can you try one more example which is a previous gate question only? Yeah, let me take this one. Yeah, in answering a question, in answering a question on a multiple choice test. Yeah, you can take in brackets which is a gate exam only. You took test. Yeah, gate exam. A student either knows the answer Yeah, usually you people will do it as this only, na? Either knows the answer or guess the answer. Am I correct or not? This only you will do it as. A student either knows the answer or guess the answer. Let P be the probability that student knowing the answer to a question. Let capital P or small p, whatever it may be, let P be the probability that student knowing the answer to a question, and 1 minus P be the probability that student guessing a answer to a question, right? Yeah, assume that if the student guess a answer to a question will be correct with the probability of 1 by 5, right? Then what is the conditional probability that if the student knew the answer to a question, given that he answered it, he or she, whatever it may be the thing, he answered it correctly. This is the question, ma. Just question seems to be big. If you understood this, it's more than easy. See, in answering a question to a multiple choice test like GATE exam, the student either knows the answer or guesses the answer. Usually all the people will do it as. So let P be the probability that student knowing the answer, and 1 minus P be the probability that the student guessing the answer. So by seeing itself the known events, what is the known events, ma? Knowing the answer and guessing the answer. That is a 2 events. Then assume that if the student guesses a answer to a question will be correct with a probability of what? 1 by 5. So while guessing the answer, means student if guesses the answer, then it is correct. If it is correct, then that is a probability is what? 1 by 5. Suppose if student is knowing the answer and he answered correctly, then there the probability is what? Directly, which is a 1, you can have it as. That is nothing more than that. See, assuming probability will be 1 by 5. Exactly knowing answer will be what? Exactly 1 only. It's 100% sure that. Then what is the thing they are asking? What is the conditional probability that if the student knew the answer to a question that he answered it correctly? Am I correct or not? So that is a question they asked you here. Am I right or not? So let me consider the steps here. What is the first step here, ma? What is the first step? Same to the earlier thing. What is the first step here? Known events. So what is that? What is the probability of knowing the answer? P. What is the probability of guessing the answer? G, which is nothing but what? 1 minus P. Am I right or not? Next, second event. Unknown event. What is that unknown? What is that unknown event, ma? He answering correctly. Am I right or not? Whether he guessed or exactly known, that he don't know. So thing will be what, ma? Answered correctly to a question. That is the unknown event. He must be answering correctly. Am I right or not? That is a event E I used to take it as. Am I right or not? Next, what I need to do it as? What I need to do it as? So the third step will be what ma? I need to represent the probability of unknown events in terms of known events. So which is unknown event in terms of known. So E given K and similarly E given what? The guessing. Am I right or not? Yeah. Can you tell me this one will be this? They had given it as what ma? Knowing answer is what exactly? If he knows and he answered it correctly, 100% correct. So hence one will be that. And guessing means the given in the problem. This is what 1 by 5 they had given. Then the fourth step. Unknown events. Probability of this you have to calculate it as. Total probability I have to do it as. So probability of E is nothing but what ma? E is nothing but what? Probability of K intersection E plus a probability of what? G intersection E. Yeah, this is nothing but the total probability, which is a total probability you have to do it as. So which is a probability of K into probability of E given K plus probability of G into probability of E given G will be there. So substitute these values. If you substitute this one, probability of K is what? P. E given K is 1 plus G is what? 1 minus P into what? This one will be 1 by 5. So if you simplify it as, you will have it as 4P plus 1 divided by 5 will be there. So check it out. If you simplify this, this you will have it as. Then what is the last step? Fifth one, reverse probability. Am I right or not? So last one will be what? Reverse probability. So reverse probability means what? Probability of K given E you have to do it as. What is the probability of K given E here? Again, same as this of your earlier case ma. Try to concentrate here. Nothing more than that. Nothing I'm doing here. So here, this again, probability of what? Yes or no? Getting what I'm saying here? I think you people are following me here. Am I right or not? So here you will have it as probability of K and probability of E given K divided by probability of E will be there. So if I substitute these values, what's the probability of B? What's the probability of B? Sorry, probability of K, which is P, and the probability of E given K is what ma? 1 divided by probability of E is what just now you calculated, which is 4P plus 1 divided by what? 5 will be there. So you simplify it as, you just try to simplify this ma. This goes to that. So you will have it as what? 5P divided by 4P plus 1. So where always you know that probability which is lies in between 1 ma, which is your previous question. So nothing is there. Don't be panic while solving the problem on the Bayes theorem. So just you have to follow the 5 steps. So if you are following the 5 steps, you will have the answer properly. Am I right or not? Yes? Yes or no? Yeah. Yeah. So that is how you people have to solve the problem based upon the Bayes theorem as well as the total probability. And let me try one more problem, which is a GATE 20 question. So let me take the recent question, which is a GATE 20. Right. So let me consider that. Consider two identical bags. Write on the question. Consider two identical bags. Consider two identical bags B1 and B2. B1 and B2. Each containing 10 balls of identical shapes. Each containing 10 balls of identical shapes and sizes. So bag B1 contains bag B1 contains 7 red and 3 green balls. Right, while bag B2 contains 3 red and 7 green balls. A bag is picked at random. A bag is picked at random and a ball is drawn from it. And a ball is drawn from it. Which was found to be red. Which was found to be red. The probability that the red ball came from bag B1 is dash in brackets rounded off to 1 decimal place. Rounded off to 1 decimal place is so the probability that the red ball came from bag 1 that is B1 is dash rounded off to the 1 decimal place. Rounded off to the 1 decimal places. This is the question they had given. So try to understand the question. It is also an applicable of what the application of your Bayes theorem only. The given question is consider the two identical bags. So two identical bags, that is a B1 and a B2, each containing 10 balls. Okay, so there are two bags are there and it is containing 10 balls with the identical shapes and size. Bag 1 contains 7 red balls and 3 green balls, and bag 2 contains 3 red balls and 7 green balls. Am I right or not? So this is how they are taking. And a bag is picked at random and a ball is drawn from it. So a bag is picked up at random and a ball is drawn from it, which was found to be a red. So then what they are asking, what is the probability that the red ball came from bag B1? Am I right or not? So they did not know that they picked a bag. Am I right or not? So but and they picked a bag at random and a ball is drawn from it. Am I right or not? So the ball is red, but they don't know the bag. So that you have to calculate it as. Am I right or not? So what is the probability that the red ball came from bag 1? So this is the question they had given. Am I right or not? So apply, do that. What is the first one? Write the known events. So what are the known events? My first one is what bag B1 and B2. Am I right or not? So there are two bags are there. Two bags. Am I right or not? So what's the probability of getting B1? Only 2 will be there. So which is 1 by 2, and probability of B2 bag 2, which is also what 1 by 2. Am I correct or not? Yeah, this one. Next, second one will be what event. So it is an unknown event. What is that unknown event here? Yes ma. So a bag is picked at random and a ball is drawn from it, which was found to be red. So that ball or that red ball from bag B1. So that is what the unknown event. So red ball from bag B1 you need to calculate it as. Am I right or not? Yeah. Then again third step, what is that? Third one will be what ma? Third one will be what? Writing unknown events in terms of known events. So which is in the form of your what? It is a probability of E, which is equal to what? Probability of bag B1 intersection E plus probability of what? Bag B2 intersection E. Yeah. So write this probabilities, probability of B1 into probability of E given B1 plus probability of B2 into probability of E given B2. Yes. So this you have to calculate it now. Yes. Actually this is the fourth step, I think so. Yeah. Before the third step you have to calculate that. Sorry. The third step will be what? This is fourth one. Yeah. Third step will be what ma? Writing unknown events in terms of the known events. So what are that? Probability of getting a red in the bag 1. Probability of getting a red in the bag 2. Yeah. Tell me that. What are that? So bag B1 contains what ma? 7 red balls. So that means out of 10. So hence 7 by 10. Back B2 3 out of 10. So hence 3 by 10. So substitute these values. B1 is 1 by 2. E given B1 means E given B1 means what ma? This itself. So same you can take it as that is, or else you can take it as what ma? B1 with red. Event is what? Red only na. Event is what? Red. So which you can take it as what? Probability of E given B1. This is what? Probability of E given B2. Simply for knowing this, I'm just giving this criteria. That is nothing more than that. So if you understood concept, it will be very easy. So E given B1 will be what? E given B1 will be what? 7 by 10 plus B2 will be 1 by 2 into 3 by 10. Am I correct or not? Yeah. So what is, if you simplify it as, you will have it as what? If you simplify, you will have it as 1 by 2. So that is what the thing. So from Bayes theorem, you are calculating what ma? The reverse probability. So you need to calculate the reverse probability. What is that reverse probability? Probability of B1 given red. So which is probability of what? B1 intersection red divided by probability of red R. So this event, unknown event is nothing but what? This itself we can call it as what ma? Probability of red only. Am I right or not? Yes. Don't get confused. Okay. Yeah, now this also again I will write it as what? Probability of B1 into probability of what? Red given B1 divided by this value, probability of red value. Am I right or not? Yes or no? Yes. Yeah. Then substitute that values. Yeah. So this is the reverse probability, you will get it as. So what you will get ma? Substitute the values. So you know the values, all those. So substitute that values. What's the probability of B1? What's the probability of B1 is 1 by 2. Yeah. R given B1 is 7 by 10. So divided by probability of R. That is event E. So which is nothing but what ma? 1 by 2. So this 1 by 2 will get cancelled. If you simplify it as, you will have it as 7 by 10. Which is 0.7 I think. Am I correct or not? So this is the thing which you have to keep in your mind to solve the problems based upon your Bayes theorem, right? So likewise you people have to solve, right? So if at all you have any doubts, you can ask me. I will give the clarity. Don't get bothered. Okay. So that is how you have to solve the things. So the thing what you have to keep in your mind is go with the what? The stepwise process. That's all. Nothing more than that here. Okay, so first you have to identify the there are 5 different steps I had given you here. So you need to identify the known events in the given data, which is a mutually exclusive events, and you need to select the unknown events. It should be a part of the known events. Then after that you have to write the probability for unknown events in terms of unknown event, then total probability for unknown event, then finally you people have to go for what ma? The reverse probability. Okay, so likewise you have to solve the things based upon your Bayes theorem. Right? Yeah. So this is about your criteria, ma. Okay. So now let me go with the another topic called as the random variables. The another topic called as random variables, ma. Random variables. Another topic which is called as. Okay. Yeah. The random variables means what, ma? So suppose if I toss a coin, a random variable is, so usually we will denote this with respect to your capital X, capital X and capital Y. Okay, so the random variable is nothing but what? Suppose if I take an example of tossing a coin, what is the head and possibilities? The sample space, getting head and tail will be the possible cases. Am I right or not? So getting head is 1 by 2 and getting tail is also 1 by 2. So I'm connecting that outcomes of an experiment with a real values is called as the random variable. So that random variable it may be a one variable or a one dimensional random variable or a two dimensional random variable. Am I right or not? So it depends upon the data what we are taking here. So let me take the definition of that random variable. Connecting outcomes of an experiment. Connecting the outcomes of an experiment. Connecting the outcomes of an experiment with the real values. With the real values is known as random variable. Is known as random is known as a random variable. Okay, right? So corresponding to, suppose if I'm taking that as a one-dimensional random variable, suppose if I take that as a one-dimensional random variable, so this I should take it as simply a random variable, one-dimensional random variable, and the corresponding data is called as, and the corresponding data used to call it as, and the corresponding data is known as univariate data. I used to call it as univariate data. This used to call it as univariate data. Then similarly, if I go with for a two-dimensional random variable, if I go with the two-dimensional random variable, so connecting two-dimensional, if I go it as connecting the two outcomes, at a time to the one real value, at a time to the one real value, provided those two outcomes are drawn from same sample space. From same sample space, the corresponding data, data is known as bivariate data. Bivariate data. Am I right or not? So nothing is there here. So for understanding purpose, let me take an example. Let me take the example here. So tossing a coin. Take an example. Tossing an unbiased coin. Right. The sample space is head and tail. So in that, probability of getting head is 1 by 2, and the probability of getting tail is also what? 1 by 2. Am I right or not? So probability of getting head is 1 by 2 and tail is 1 by 2. Suppose if I'm connecting this with respect to a real value, so what I'm taking is, I'm just connecting this with respect to a real value, right? So this is, if you take it as the x-axis as well as your y-axis, this is my x-ma, and a real value or y you take it as. So here let me take this one, or the probability you take it as, that is not a big deal. That value I'm just taking here. So this is a 0. See, suppose what is the probability of getting a head value here? I'm having here what, 1 by 2. And similarly, probability of getting tail is also what? 1 by 2. Some value will be there. Am I right or not? So this, I'm just connecting the outcomes, the possible outcomes of an experiment to a real value. So that real value will be this one. So hence I'll call that as what? The random variable. So maybe EC people, you know that random variable, that and all you people studied in your the noise analysis. Am I right or not? Yes. Yeah, that is how you people will see it. Suppose if I take the random variable, suppose if I'm having this random variable here, yeah, this is in the part of your discrete as well as your continuous part. One is a discrete random variable, and the other one is continuous random variable. With respect to this discrete random variable, we will see the probability mass function, or which is also called as probability distribution function. With respect to continuous, you will see it as probability density function. Okay. Clear with my point? So here you will have the distributions like I already told you that you will have the different distributions like binomial distribution and Poisson's distribution. Binomial distribution and Poisson's distribution. In the part of your continuous, you people will have different strategies. One is uniform, or also called as the rectangular density function. Next, normal distribution, or also called as a Gaussian distribution. This you will see in the exam point of view. Okay, these things you will see it as the exam point of view. So now the next one will be the statistical averages. Statistical averages of a random variable. Statistical averages means what, ma? Statistical averages of a random variable, we will do it as. Okay. Or else before going into that, first let me give you the difference between your the distribution as well as the density function, or whatever it may be the case. Yeah. So let me take the statistical averages. We are not an issue. We will discuss this one. The statistical averages, in that first we will see it as the mean, or also called as expectation. Mean or expectation. So here I need to write with respect to both the cases. With respect to both the cases. Am I right or not? For both the cases, like continuous random variable as well as your discrete random variable. Continuous as well as your discrete random variable. I think, yeah, see ma'am. In order to get these analysis of this mean and expectation, first let me give you the thing with respect to what do you mean by. So you need to get the clarification of your what. You need to get the clarification of your the distribution as well as the density function. First I need to give the clarification. Let me take an example. Go with the distribution as well as density function. Then I will give you the statistical averages. Because first you have to get what is the meaning of your see here. This is your probability distribution function, and this is your probability density function. So distribution will be capital PDF and density will be small PDF. I will give you the clarity first, then I will go with the another cases. So let me take the first one will be the probability distribution function. Probability distribution function, which is denoted with the capital PDF, which is also called as a CDF, cumulative distribution function, which is also called as cumulative distribution function. Cumulative distribution function. Why means I'll tell you at the end of the thing, so that you will have an idea, which is also called as the cumulative distribution function. These both are one and the same. Okay. Yeah. So here let me take a random variable. Usually this we will denote with respect to capital F of X. This that we will denote with respect to the capital F of X. Okay. So that distribution you people have to take it as capital F of X. So consider X is a random variable. Consider capital X is a random variable. Capital X is a random variable. Then the probability distribution function. Then capital PDF is given as, that is capital F of X, which is equivalent to probability of X is less than or equal to X. Probability of X is less than or equal to X. So this is the distribution function PDF. So if I take an example, suppose if I take an example, F of 10 if I want to, or F of 6 if I want to calculate it as. So you'll have it as what? Probability of X is less than or equal to 6. In between 0 to 6 you have to, because the probability lies between 0 to what? 1. So that is the reason why it starts with that one. So hence I will calculate that particular criteria. Getting what I'm saying here? Understood? Yeah. So let me take the consideration of that example, that is how I have to sketch the probability distribution function. Consider the dice experiment. Consider the dice experiment. So what is a die is rolled? What is the sample space? What is the sample space actually? 1, 2, 3, 4, 5, 6. If I throw a die, what is the sample space? If I throw a die, the sample space is what? Yeah, you will have it as 6. So let me take my random variable. Let me take my random variable capital X. This is my random variable, and distribution function I'm taking it as, which is x is less than or equal to x. I'm just taking it as, so which is also equivalent to what? My probability of x is equivalent to x. I have to take it as. So what is the probability of getting 1? What's the probability of getting 2? This 3, 4. So can you tell me what is this? Can you tell me what is this, ma? What is this values? Yes, tell me. What's the probability of getting 1? Which is nothing but what? 1 by 6. This is also 1 by 6. This is also what, ma? 1 by 6. This is also what? 1 by 6. This is also 1 by 6. This is also 1 by 6. Am I right or not? So which are the concept of your what? The probability thing. Yeah, then how I have to represent, or how I have to sketch the probability distribution function. So how I need to sketch the distribution function? Let me take this is my, yeah, here I'll have 0, 1, 2, 3, 4, 5 and a 6 mark. So let me take this is my probability distribution function. Let me take it as. So kindly consider what you are having at 1 mark. So to make the total probabilities, check it out here. The total probability, if I add all those, you will have it as what? Answer as what? 1. So in such a way that I need to make that as a what? The different strategies. So there at probability 0, from 0 to 1, that probability value is what? 0. Then what about at 1? I'll have here what? 1 by 6. This value will be what, ma? 1 by 6. Then again at 2. At 2, what people are having there? At 2 also you'll have 1 by 6. So I need to take it as what, ma? I need to add it as this one. 1 by 6 plus 1 by 6. So why? Because which is nothing but what? Probability of x is less than or equal to x. So hence less than or equal to x means, suppose if I want to calculate up to probability x is equal to 2, ma. X is equal to 2 means both 1 and 2 I need to calculate it. Suppose if I want to get x is equal to 3, I need to add all these 3 things. 4 means again I have to add it as. So likewise, so I need to cumulatively add all these things. So I need to add all these cumulatively. That is the reason why this is also called as what, ma? Cumulatively I am adding here, which is also called as what? The cumulative distribution function. So at 2, you people are having what, ma? Which is nothing but what? Which is 2 by 6. At 2 you are having what? At 2 by 6. Then similarly at 3 you will have it as what? Again 3 by 6 will be there. So likewise it will be extending. Am I right or not? So 3 by 6, 4 by 6, 5 by 6, 6 by 6, which is what, ma? Finally it will have this in the place, which is nothing but what? 6 by 6, which is 1 you people are having it as. Am I correct or not? Am I correct or not? So this is how you people have to do this. I am calling it as capital PDF, which is also called as a cumulative distribution function, CDF, that is capital f of x. So this is a random variable x. So this is how I have to sketch. I have to sketch with respect to the distribution function. Yeah, can you take from this analysis, can you give me these values? What is your f of 0.3? What is your f of 0.99? Can you tell me what is these values? F of 1 will be what? Then f of 1.9, what is this? Then f of 2 will be what? Then can you tell me what is f of 6? Can you tell me what is this? All these are all what, ma? The distribution functions. Am I right or not? So how I can able to get that distribution functions? So try that. Try to give me the values for that. So you know that f of x will be what, ma? Probability of x is less than or equal to that one. So give that value in that particular criteria. Yes, give me that value. So how we will get it as? See, this I can represent as what? Probability of x is less than or equal to, yeah, 0.3. Up to 0. Up to 1. At 1 only I have the value of what, ma? At 1 only I have the value of 1 by 6. So up to that value will be what? 0. Similarly, this also probability of x is less than or equal to 0.99. So hence this also 0. This one probability of x is less than or equal to 1. Up to 1 it will be that. So which is nothing but what? 1 by 6. Am I right or not? Yeah. Next one. 1.9 means what? Again, probability of x is less than or equal to 1.9 which is having. So what is this value? 1.9 means what? Again 1 by 6. Exactly at 2, then only you will have the value of what? Then only you will have the value of what? 2 by 6 will be there. Then it is probability of x is less than or equal to 6. So less than or equal to 6 means what? At 1, 2, 3, 4, all the things you people have to add it as. So this is the answer for that. Getting what I'm saying here? That is how you people have to do the analysis. Clear with my point? Getting what I'm saying? Yes or no? Am I right or not? Yeah, that is how you people have to sketch the things with respect to the distribution function. Okay. Yeah. Now let me take the properties. Let me take the properties of your probability distribution function or cumulative distribution function. The first property will be, which is 0 is less than or equal to f of x is less than or equal to 1. Then next one, what is your f of infinity plus infinity will be what, and what is your f of minus infinity? Can you tell me what is this values with the definition? Which is nothing but what? Probability of x is less than or equal to infinity, but total probability lies in between 0 to 1. So which is nothing but what? Probability of x is less than or equal to minus 8. So which is nothing but what? 0. Am I right or not? Yeah. So likewise you have to go it as. Then one more thing. Next property, which is nothing but what? Probability of x is greater than x1. So this I can represent as what? 1 minus f of x1 I can do it as. So take an example of your above thing, dice experiment only. If I take it as, what is the probability of x greater than 5? What's the probability of x greater than 5 if I take it as in a dice experiment only I am calculating here. Yeah, if I calculate, so what is this value? Probability of x greater than 5, which is equivalent to what? 1 minus f of 5 will be there. So which is what? At f5 we will have it as what? 5 by 6. So 6 minus 5, which is what? 1 by 6. I can able to calculate it as. So likewise you can have some properties, some of the properties of this criteria. Getting what I'm saying here? Yeah. Similarly, one more thing. What is the probability of x1 is less than x is less than or equal to x2? So which is nothing but what? F of x2 minus f of x1 will be there, right? Yeah, this is one more property. The same dice experiment I am taking an example. Probability of 3 is less than x is less than or equal to 5 if I want to calculate it as. So what the value I will get as here? Again f of 5 minus f of 3 will be there. So you know f of 5 is 5 by 6 and f of 3 will be what? 3 by 6. So which is nothing but what? 2 by 6. That is what directly you can tell it as what? Answer as 1 by 3. So likewise you can go with this. And one more property, a probability of x is equivalent to x1, which is equivalent to f of x1 minus f of x1 bar. X1 bar means less than the value of your what? X1. Some slight less than value of your x1. So let me take an example here. If I want to calculate probability of x is equal to 2, this is nothing but what? F of 2 minus f of 2 bar. 2 bar means what? Less than the value. So if I take f of 2, this value will be what? F of less than the value of 2 means 1.99 also you take it as. So let me take this one. What is f of 2? 2 by 6. And f of 1.99, 1 by 6 will be there. So resultant will be what? 1 by 6. So likewise we have to go with that. Next, the last property. The last property, which is property number 6. If you check it, the probability distribution function, what I told you, see I sketched here. So this is what? The staircase waveform. So which is all what? It's an increasing function or not? Yes or no? So always, that is your probability distribution function PDF is probability distribution function is what? Increasing. Probability distribution function is increasing function. Probability distribution function is increasing function. You people have to do that. So this is about the part of your what? Probability distribution function. Next, the other one is what? Probability density function. So let me take probability density function. So there is a difference between distribution and density. Distribution means capital PDF, density means small PDF. Don't get confused. Distribution means capital PDF, density means small PDF. Yeah. So actually this density function you people will have it as, so small f of x is equivalent to d by dx of f of x here. So this is the density function. This is the part of your density function. So here if you observe here, this small f of x is probability density function. Small f of x is probability density function, and capital F of x is what ma? Probability distribution function. Probability distribution function. Don't get confused. See, once if you know one thing, you can calculate the other thing here. Suppose if I want the relation between this one, f of x, if I want to get it as. So how I will do that my f of x? How I will do that my f of x? Yes. How I will do my f of x? I will get my f of x is what? My integral minus infinity to here it is what? The relation between differentiation. So one thing if you are having differentiation, the other one will be what ma? Integration. So capital F of x will be what? Dx you will have it as. This is also the another criteria. Am I right or not? This is also the another criteria which with respect to what? With respect to people have to take it as what ma? The another strategy. So this is one strategy and this is what ma? The another strategy. So capital F of x is the distribution function and small f of will be the density function. So here also you can tell it as what? Here also you can represent this capital F of x is what ma? Capital F of x is what? Probability distribution function. Capital F of x is probability distribution function. And small f of x is what? Probability density function. Probability density function. Am I right or not? So this is how you have to keep in your mind. Then excuse me. Yeah. So this is the difference between a density function as well as your distribution function, right? So let me continue with this. So earlier I taken an example. For that example, can you give me that the density function? Yes. Yeah, actually I taken your earlier example. Earlier example is nothing but what ma? Distribution function I had taken. For a day experiment I sketched this the distribution function. So once if you know the distribution function, you can go with respect to what? The density function. Am I right or not? So what is the density function ma? How I can able to mention the density function? Yes. Yeah. So can you sketch the probability density function for the above example? So if I take the probability distribution function, if I take this probability distribution function, this is 0, 1, 2, 3, 4, 5 and 6. This is capital F of x. Which is a 1, okay. Yeah, so this is your probability distribution function, and that you know that what is the differentiation of this one. For this I need to sketch the differentiation. So you know that ma, what is what I can say that the differentiation of your unit step ma, you know, impulse function. Am I right or not? So at each and everything you people will have it as what? The impulse function. You check it out. 1, 2, 3, 4, 5, 6. So differentiation of step will be what ma? Impulse. This is a differentiation property, and differentiation of a constant will be what? Differentiation of constant will be 0. This is the property that you know that. So now if I sketch these things, so here I'll have a what ma? Everywhere you will have an impulse. Everywhere you will have an impulse. Am I right or not? Yes. Everywhere you people will have an impulse, which is nothing but what? 1 by 6 you will have it as. So check it out everywhere, right? So this is your capital PDF. This is your small PDF. Am I right or not? Yeah, if you observe this from 1 to 6, this is what? from 1 to 6 it is uniformly distributed, so hence 1 by 6 will be there. So this is also called as what? The uniform density function, which is with respect to the discrete values. So likewise you people have to go with the analysis of this one. So this is the part of your density function. See, once if you know the distribution function, then you can differentiate the density function, you will get it as the distribution function, you will get the density function. Am I right or not? Okay, so likewise you have to solve the things. So let me take some properties of this probability density function. Properties of your small PDF density function. Properties of density function. So the first most property which is very important. Every problem is based upon this property only. So integral minus infinity to plus infinity f of x into dx, which is equivalent to 1 So if you take integration means what? The area. So that is area under any probability density function. Area under any probability density function is 1. So that means if you check it here, this also. See, this if I take it as, so 6 will be there, 6. So area will be what 1 only. So that is the reason why area under any probability density function, area under any probability density function is always is equivalent to 1. Right? So every problem we will solve based upon this criteria only. Next, probability of x which is less than or equal to x1. Probability of x is less than or equal to x1. This I can represent it as capital F of x1, distribution function. So that value, see here, probability is starting from, see, this value will be from minus infinity and it will ends at what x1. So hence it starts minus infinity and ends with x1. So which is nothing but what? F of x into dx. Then similarly you people will have it as what? Probability of x is greater than x1 if I take it as. So this I can represent it as what? 1 minus probability of x1 I have to write it as. Then again it starts from x1 and ends with infinity. So don't get confused for those cases. So x1 to infinity f of x into dx you will write it as. Clear with my point? Then similarly the last point, which is nothing but probability of x1 is less than, x is less than or equal to x2 if I'm writing it as. So this I can represent as, see, earlier difference between that. Now it is in between x1 to x2. So hence x1 to x2, x1 to x2, f of x into dx. So these are the some of the properties which you have to keep in your mind to solve a problem on your what? This density function. Okay. Next, let me take one more example. Right, uniform density function uniform density function, which is called as a uniform density function, or also called as a rectangular density, that I already told you that, which is also called as rectangular also. Okay, yeah. So it's a simple statement. If the given probability density function is constant within a specific range, then that particular random variable is said to be uniformly distributed. So if the probability density function, yeah, yes, uniform density function is if the probability density function, that is a PDF is a constant within the specified range, then the random variable is said to be uniformly distributed. So that means the probability density function is constant within a specific range, then that random variable is said to be uniformly distributed. So that means, take an example. Let me take an example. So if I take your earlier example only, what is that? That is a probability density function if I take it as. So which is a small f of x I'm taking here. So 0, 1, 2, 3, 4, 5 and 6 if I'm taking it as. So which is x. So this is, you will have it as what? For all the cases, you are having an impulse. You are having an impulse with this analysis. Am I right or not? So this will be what now? 1 by 6. So if you observe here, from 1 to 6, this value will be constant. So hence this one, see, and that too particularly it is a discrete ma. See, if you are observing here, at 1 exactly 1 you are having 1 by 6. Am I right or not? At 2, 1 by 6. In between 1 to 2, there is no value. In between 1 to 2, there is no value. Yeah, if you observe this, from 1 to 6 it is the constant value. So 1 to 2 there is no value. So exactly 1 you have value, exactly 2 you will have a value. So hence I can call this is a discrete random variable. This I can call it as discrete random variable. Okay. Yeah. Then similarly I will take one more example. Similarly, if I take one more example, the continuous one, if I take one more continuous, which is 1, this is a f of x if I take it as. So from a to b I am just taking here, this is a, this is a b. So this value, so if you are observing from a to b, this value is constant. Am I right or not? So this value I am taking it as what? 1 by b minus a if I take it as. So this is, I'll take it as what? Take an example ma. So this you take it as a 5, this you take it as a 10. So which is nothing but what? 1 by 10 minus 5, which is what ma? 1 by 5. Area will be what? 1. So this I am calling it as the continuous random variable. Am I right or not? So this is the difference between the discrete random variable as well as your continuous random variable. You got my point clearly? So this is the thing which happens with respect to that. So for understanding this distribution as well as density function, in order to understand this density function and distribution function, let me take an example. Let me take an example. Right, a random variable capital X, a random variable capital X is uniformly distributed. A random variable capital X is uniformly distributed in the interval 0, 10. Sketch the probability density function. Sketch the probability density function. Also calculate the following. Also calculate the following. A random variable capital X is uniformly distributed in the interval 0, 10. Sketch the probability density function. Also calculate the following. First one is probability of X is less than or equal to 2. Second one, probability of X is greater than 9. Probability of X is less than or equal to 2, and probability of X is greater than 9. And third one, probability of 3 is less than, X is less than or equal to 7. These three quantities you people have to calculate it as. So they told that a random variable capital X is uniformly distributed. A random variable capital X is uniformly distributed in the interval 0, 10. For that you need to sketch the probability density function, capital PDF. So uniform density function means what ma? So I am just trying to sketch this one. Let me take this. This is an X. This is capital F of X. So which is uniformly distributed from 0 to 10 ma? Which is uniformly distributed from 0 to 10. Yeah. Suppose if I take this is an uniformly distributed. Can you tell me what is this value? 1 by 10 minus 0, which is what ma? 10. So which is your probability distribution, density function. Am I correct or not? From 0 to 10. Yeah, and they are asking what ma? They are asking what probability of X is less than or equal to 2. So let me take the first one. Ma. You need to calculate what probability of X is less than or equal to 2. From the property of your what? From the properties of your what? Uniform density function. So which is X is less than or equal to 1 means what ma? From minus infinity to x1, integral f of x into dx. So that is what the criteria. So let me take this, let me take that here. So I'll have here what from infinity, from infinity, but it is starting from where? 0. So you need to take 0 to 2 integral f of x into dx. You have to calculate it as. So try to check it out. If I take this is 0 to 2 so up to here you have to calculate the area. So integral means what? The area only na. So what is the area of this one What is this area? This is 2 minus 0 into what? 1. So 2 into 1 by 10, which is nothing but what? 1 by 5, which is what 0.2. This is that area. Similarly, can you calculate what they given? Probability of x is greater than 9 x is greater than 9 means same as your the property, same as is of that property. If I take it as, I'll have here what? Integral 9 and it ends with 10. Again it is nothing but what f of x into dx. So if I want to calculate this, what I will do it as 9 if I take it as somewhere here. So this is 9 if I am taking. So this one again you need to calculate what this area you have to calculate it as. That area you have to calculate as. So that area means what? 10 minus 9 into 1 by 10 is the area. So 1 by 10 which is nothing but what 0.1. That is how you people have to do it as that problem. Next last problem is what? Probability of 3 is less than x is less than or equal to 7 they are asked you. So how I have to take it as this one again from 3 to with the help of your property 3 to 7 f of x into dx. So this you have to take it as. So from 3 to 7 means what This is a 3 if I take it as, this is a 7 if I take it as. So in between 3 to 7, in between 3 to 7 I have to calculate the area. Am I right or not? So this is 3 to 7 I need to do it as. Am I correct or not? So this will be what? 7 minus 3 into again what? 1 divided by 10. That is 4 by 10 This I can represent as what? 0.4. So that is how I have to solve the thing based upon your distribution as well as your what density functions. Clear with my point? Understanding what I'm saying here? Yeah, that is how I have to go with the concept of this one. So based upon that you will solve those things. Okay, so now let me take so once if you understood this properly, I'll go with the statistical averages. That is very important. Statistical averages of a random variable. Statistical averages of a random variable. Statistical averages of a random variable. So what are the different types of statistical averages here we are having? So first let me take the first one is a mean value, which is also called as expectation. Mean or expectation, right? Yeah, so this will denote with respect to different criteria. Mean value or expectation value will denote with respect to different analysis. Okay, right? Yeah, so mean value will be x bar or expectation a of x, which is also equivalent to what m1 movement, central ladder movements. So this is given by integral minus infinity to plus infinity x into f of x dx for continuous random variable. For discrete random variable which is a summation. So n is equal to 0 to infinity x into p of x. So try to understand this is continuous random variable and this is what discrete random variable. So what is the difference between this? Continuous random variable integral values, discrete random variable summation, and moreover in the continuous random variable here we are taking the this small f of x is what distribution function, sorry, density function, small PDF. This is your what small PDF you have to consider it as. And here this p of x is nothing but what probability. Don't get confused This is your direct probability value. Don't get confused. In the continuous random variable you are taking a density function, and discrete random variable you are taking what the direct probability value, because it is a discrete random variable. Am I right or not? So this is the part of that one. Similarly based upon that you can go with respect to what the mean square value, which I can call it as MSV used to call it as. So nothing is there for mean, just I am doing it as what the square value. Am I right or not? So this is central order movements, I can call it as central, that is a first order central movements, we can call it as first order central movements, we can call it as the terminology, that's all, nothing more than that. first order central movements. Then similarly, if I go with the mean square value, which I used to call it as x square, that is x bar square, e of x square, which is equivalent to m2, we will call it as. So for just a square, for mean you are doing this is x, here you are having what, x square. So x square into f of x dx, which is again what, summation x is equivalent to 0 to n x square into p of x, you have to do it as. So likewise you people have to solve the things, right? Then next one, third one will be what, variance. Third one will be the variance. Third one will be the variance. Usually variance we used to take it as sigma square. Variance will denote with the sigma square. Variance we will denote with what, sigma square. So variance is equivalent to usually this is a sigma square, which is a variance of x, which is what, usually mean square value minus a mean square value minus a mean whole square, you will denote it as mean square value minus mean whole square. So that is mean square value is x bar square minus x bar whole square, which is also you can represent as e of x square minus e of x whole square. Am I right or not? Then similarly this is also, these are all the things, the notations, that's all. With respect to this one, m2 minus m1 square. So like that you can have the things. This is about the mean square value. Then last one, standard deviation. Last one will be what? Standard deviation. So which I can represent as sigma, standard deviation. So that is standard deviation sigma is equivalent to root of variance, under root variance. That's all. This is we used to take it as the standard deviation. So these we are calling it as, this we will call it as what, these things we will call it as what, the statistical averages of a random variable. That we will call it as the statistical averages of a random variable. Am I right or not? Yes, yeah. So for understanding this, let me take the examples. For understanding how I have to calculate the mean and variance for the thing. So let me take the example, right? So find the expectation and variance. Find the expectation and variance. Find the expectation and variance of the number on a die, when it is thrown. Find the expectation and variance. Find the expectation and variance of a number on a die when it is thrown. Yeah. So let me take this is an example. So you know that if I throw a die, what is the sample space actually? If I throw a die, what is the sample space? 1, 2, 3, 4, 5, 6. This is the sample space. Am I right or not? So let me take what's the probability of getting 1 that you already calculated. Probability of getting 1 is nothing but what, probability of getting 1 is what? 1 by 6. Probability of getting 2 is what? Also 1 by 6, and so on. Probability of getting 6 is also what? 1 by 6. So let me take a random variable. Let me take the random variable x and probability of x. This is what you are calculating. What is the random variable here? Random variable x means what? 1, 2, 3, 4, 5 and 6. So if I take the tabular column for this, yeah, this is a random variable. For that random variable, I'm just taking these are the different values here. Am I right or not? So let me take this so that you will have an idea. Yeah. So what is the probability of this? What is the probability of this? Getting 1 is 1 by 6. Getting 2 is also 1 by 6. This is also 1 by 6. Am I correct or not? Yeah. Now I need to calculate. If you observe this, it is a discrete random variable. If you observe this, which is nothing but what? A discrete random variable. So for a discrete random variable, what is the expectation or mean for a discrete random variable? Because at 1 by 6, in between 1 to 2, You don't know the value. Am I right or not? So for a discrete random variable, what is the mean or expectation? What is the mean or expectation, ma? Which is E of x, if I take it as the mean or expectation, which is nothing but what? Summation x is equal to 1 to 6 for this. You will have it as what? X into P of x. Am I correct or not? So how I will calculate this one? Which is nothing but what? Expand this one. Summation, if I expand this one, ma, so 1 into what? P of 1. If I expand this one, then similarly 2 into what? P of 2. So plus and so on. You will have it as what? 6 into P of 6 will be there. So now if I substitute 1 into 1 by 6 plus 2 into 1 by 6 plus and so on, you will have it as what? 6 into 1 by 6 will be there. So now if I take 1 by 6 as a common, 1 by 6 if I take it as a common, 1 plus 2 plus 3 plus 4 plus 5 plus 6 you people are having. So if you simplify it as, you will have it as what, ma? 7 by 2. So this is the mean or what? The expectation. Suppose if I want to calculate the variance, ma. See, if you want to calculate the variance value, you require what? The mean square value. So what is again the mean square value? Mean square value will be what, ma? E of x square. So that is nothing but what? Summation x is equivalent to 1 to 6 x square into P of x. Similar to our earlier case, just square I need to do test. So that is 1 square into P of 1 plus 2 square into P of 2 plus and so on. You will have it as what? 6 square into P of 6 you will do test. So now substitute this value. So what? 1 into 1 by 6. Then 2 square. 4 into 2 by 6. Sorry. 4 into 1 by 6. Plus then again what, ma? 9 into 1 by 6 plus and so on. 6 square means 36 into 1 by 6 you will have it as. Am I correct or not? Yeah. So now again if you take it as a 1 by 6 as a common, you will have it as what? 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided by 6. So you will have an answer of what? If you do that, you will have it as what? 91 by 6. So now I require the variance. So that is the variance. How I will calculate it as? Variance V of x is equivalent to E of x square minus E of x whole square. Am I right or not? So this gives you E of x square will be what, ma? 91 by 6 minus 7 by 2 is your E of x whole square. If I do it as, if you simplify it as, you will have it as what, ma? 35 by 12 you will get this. Check it out. That is a 49 by 4. So 91 by 6 minus 49 by 4, which is nothing but what? 35 by 12. So this is how you people have to calculate the things with respect to what, ma? The things with respect to what? The things with respect to what? The mean and variance. You have to calculate the mean and variance. You have to calculate with respect to the die. See the same. Can you repeat? 3 unbiased dice are thrown. Then find the mean and variance. Can you calculate that one? For the same, can you repeat the above example? Repeat the above example. Repeat the above example for 3 unbiased dice are thrown. 3 unbiased dice are thrown. Dice are thrown. So how you people will do it as? Check it out. Then no need to go for again all these things. Must see if I throw n number of dice. What is a sample space? 1, 2, 3. That is 3 dice. If I am throwing 6 power 3, you will have that one. But getting 1, for getting 1 is nothing but what? 1 by 6. Getting 2, 1 by 6. Getting 3 is also what? 1 by 6. Am I right or not? So no need to do that one. So this is again one more example you have to calculate it as. But if you observe properly, make a note point of this one. Make a note point of that. Right. So in number of dice if you are throwing, getting probability of getting 1 is 1 by 6. Getting 2 is 1 by 6 only. But there is no change. But the number of dice will be multiplied. The number of dice will be multiplied. Am I right or not? So that is the reason why make a note point of that. The mean and variance. The mean and variance for the sum of the numbers, for the sum of the numbers on the die, what? On the number of on the numbers on the die is that is expectation of x is 7 by 2 is fixed, but it depends upon the number. If it is a 3 number means it is multiplied with n. Then variance will be what? Variance of x is equivalent to what again? 35 by 12 is constant, which is multiplied by n. Am I right or not? So this is very, very important. So with that knowledge, if it is a 3 dice, 3 unbiased dice are thrown. So for a 3 unbiased dice, so n is equivalent to 3, right? So what is expectation? E of x is equivalent to what, 7 by 2 into 3, which is what? 21 divided by 2 you will do it as. Similarly variance will be what, V of x is equivalent to what? 35 by 12 into what again? 3, which will be there. So 3 ones, 3 fours. So that is what, 35 divided by 4. So you will take it as these values. That is how I have to generalize this one. Clear with my point? Getting what I'm saying? All? Yes or no? Yeah. That is about the particular criteria. Then similarly for continuous random variable. One more thing. For continuous random variable, can you calculate continuous random variable? For the same example I am doing for continuous random variable. So far I had taken here what, for discrete random variable. If I am taking continuous random variable, if capital X is a continuous random variable, if capital X is a continuous random variable, if capital X is a continuous random variable and probability density function is, and it's a probability density function, f of x is modulus of x minus 1 is less than x is less than plus 1. Okay, then find expectation, and variance. Then find expectation and variance. Yeah, so this is a continuous random variable. Earlier is different and this is different. For a continuous random variable, you know that for continuous, in the problem itself they told that this is a continuous random variable. For a continuous random variable, what is the expectation? For a continuous random variable, expectation is nothing but what? E of x is equivalent to what? Integral minus infinity to plus infinity x into f of x dx. Am I correct or not? Yeah. So the given function f of x will be what? Mod x, which is nothing but what? This one. So try to update here. What I'll guide as here? This will be varies from where? Yes. Yeah, for a continuous random variable, you know that the expectation of x or the mean of x is nothing but what, integral minus infinity to plus infinity x of x into f of x is the mean value. Am I right or not? Yeah. So substitute the given limits is nothing but what, from where to where? Minus 1 to plus 1. So substitute this one, minus 1 to 1, x into f of x is what? That is a mod x. So mod x into dx. So this integral value people have to do it as. So how you will do it as? Yes, yeah. So if you observe here, or else you can directly substitute as here we are having a modulus function. So you know that mod x is a plus x for x greater than 0 and minus x for x less than 0. That you have to consider it as, or otherwise you can do it as, see, check it out, you know modulus function is what, even function, and it is multiplied with what, and x is what, odd function. So any even function is multiplied with odd function, the resultant will be what? Odd with even, the resultant will be what, the odd with even multiplication is nothing but what? The odd function only will be there. Am I right or not? So, and you know the property is integral minus a to a f of x dx is equivalent to 0 when f of x is what? Odd function. And this you can represent as what? 2 into integral 0 to a. In the calculus part, if you are taking 2 into integral 0 to a f of x dx, that you can represent as what? When f of x is what, even. Am I right or not? But now that our case is what? It is a odd function. So it seems to be what? This overall function, this if I take it as f of x, that function will be what ma? Odd function. So this value directly I can make it as what? 0. Otherwise you can split it ma. That integral value you can do it as, so plus x for x greater than 0 minus x, that you have to split it as from -1 to 0 and 0 to 1 in such a way that if you are doing, you will get the answer as what? 0 only. So similarly, try to calculate the expectation of that is x mean square value. So mean square value is from -1 to 1 x square into what? Mod x. So this is your mean square value. So try to calculate this. So now this is even function. Check it out, both x square and mod x is what? Even function. So even function with even function, again you will have it as what? The even function only. So now this you can represent as what? 2 into integral 0 to 1 x square into x into dx. So x square into x will be what ma? X cube. So integral 0 to 1 x cube into dx. So integration for x cube, you know that what? X power 4 by 4. Limits from where to where? Limits from 0 to 1. So if you substitute limit, you will have it as what ma? The answer as what? 1 by 2. Then finally, what is the variance of x? Variance of x is equal to what? Mean square value e of x square and mean whole square. E of x square and e of x whole square. This is the variance. So substitute it. What you will get the variance? What is the variance here in this? Variance of x is equal to what ma? Mean square value, which is 1 by 2 and mean value 0. So the variance of x is equivalent to 1 by 2. Variance of x is equal to what ma? 1 by 2 you people have it as. So likewise you people have to solve the problems based upon what ma? You have to solve the problems based upon what? The mean as well as your variances. Clear with my point? Understanding or not? Yes or no? Yeah. So this is how you people have to solve the things. So after this we will see some of the properties of your mean, that is expectation and variances, and we will start with the problems, previous questions. Then after that we will go with the distributions, like the normal distribution as well as I told you na, Poisson's distribution, binomial distribution, and then finally the last topic will be there, that is the statistics part. So maximum I will try to cover in the next session this probability and statistics part. So this is about the particular session. In the next session I will start with the properties of mean as well as your variance, and we will solve the problems. Okay, fine. Yeah, thank you.